How are you, everybody who is watching this video? I would like to take this opportunity to welcome all physical engineering students and even also line engineering students. It's the first time to meet me. My name is Olenjolai. I'm very happy to have you. And I've prepared a very good news today about electronics engineering. Professionally, I'm an electronics and telecommunication engineer, but also professionally, it means I'm teaching electronics engineering, I'm teaching telecommunication engineering, I'm teaching about electrical engineering, biomedical equipment engineering. So it's my business. So I would like to say that I thank God who have given me a gift of engineering in combination with the gift of teaching. So teaching to me, it's a work of my heart. I like it so much. And I would like to tell you that I have a good news that I've prepared for you. These are the real classes. We have a theoretical part. The practical part for electronics drawings actually will be executing or will be performing by using the computer. We're actually called simulations, schematic circuit diagrams, that the point will be doing some kinds of the practicals to enjoy about drawing the schematic diagrams. This course is dedicated to the first year ordinary diploma student and also first year undergraduate students or bachelor degree students. But even secondary students, they can cover as long as you like or you love electronics engineering, or you love telecommunication engineering, or you love electrical engineering, so biomedical equipment engineering, or mechatronics engineering. This is the cross-cutting modules or cross-cutting course or cross-cutting subject. We have been covering some of the concept, but today we have a particular and very important concept to lay out the foundations on this technical language. Another thing which I would like just to tell you in advance, and this is the precaution, it's my own precaution. Not bear in your mind that I don't know everything about electronics drawing. I just know a small portion of it, but I'm a student of electronics drawing, and I usually learn new concepts as time goes. But I know small portions of electronics drawing, and I have a responsibility to teach others about what I know. If that's the case, I would like also to ask students, or all my students, physical and even online students, also to learn electronics drawing from other teachers, or from other books, or from other articles, to make sure that you have integrated and even actually have a strong foundation in electronics drawing. So you have to remember that every time, regardless of how quality am I going to teach you, but remember that I cannot teach you everything. I have a responsibility to lay out the foundation, but you have also the responsibility to look for some more material. So I am an open-minded teacher. I don't just fix my student that, students, you have to learn from me. No, no. You have also a chance to learn from others, because I know there are some people who knows even electronics drawing more than I know. The last thing which I want to say before we start our lecture 2, these are interactive classes. We ask students to be active. You should write. You must draw by using, you must have drawing tools, in order for to make a drawing. And then you have to ask questions. You have to listen. You have to try your level best to understand. And you should have an imagination that I won't get time to revise what I've been taught. So I just have only one chance or one opportunity to learn and understand it today and at this time. In case I get some time to review, well, but even if I don't get that time, I've understood the concept. So that's why I told you that I will teach you in a different tricks and different techniques in such a way that you will actually understand and keep the information in your mind. I have some physical students. This is our online college that's called Tanzania Online Full Technical College, where we are training ordinary diploma students. We are training them about the Word of God. We have also responsibility to train our students about basic engineering, scientific mathematics. We're also training about electronics engineering, and we are teaching also about telecommunication engineering. But also we have another department that's called the computer programming language, or just we call it computer science, but mostly computer programming language. So once you make a decision today to be our online student, then I believe that you will earn so many advantages, because through this online platform, you may learn electronics engineering, you may learn basic engineering mathematics anywhere at any time. That's the goodness and that's the power of the internet. So you're not fixed or limited being at DIT or being in Dar es Salaam. No. You may learn electronics nowadays, even if that you're in Kwara. So that the opening mindset. So you can search this, our official YouTube channel. You can search it and make sure that you register yourself by subscribing. Then get prepared to receive going on, or just we call them day after day or weekly videos. We have recorded more than 300 videos right now, specifically for Tanzania Online Full Technical College. So it's a huge, and it's growing, because as long as I'm living, I'll be adding hundreds and even thousands of the contents into this channel, because yes, I have a mission to make sure that I solve the real life technical problem and the training problems in my own country. So how are you, ordinary diploma electronics and telecommunication engineering students? Are you ready for lecture 2? Yes. Well, so let us read the name of our institution. What are the names of our institution? Tanzania Online Full Technical College. Again, say Tanzania Online Full Technical College.
Tanzania Online Full Technical College.
So the mission we have, when you say full technical college, we have just these 3 missions. Number 1, to teach students about theories of engineering. Number 2, to teach students about simulation or software parts or in engineering. And number 3 is actually to teach our students about experiments, real life experiments, how you can design some electronic system. That is in case of the hardware. In case of the software, number 1, we'll be teaching our students the theory of computer programming. Then we'll teach our students how to program or to write a program which actually can solve a particular real life problem. Are we together? Are we together? So we are very committed, and this is our daily work. So as long as we live, and I believe that even if that I will pass away or will pass away, I know that there are the number of people who actually can actually make this business to continue. So it's not limited with my presence or my absence. So which departments are we? Electronics engineering. What the models we have? Say electronics drawing.
Electronics drawing.
Say electronics drawing.
Electronics.
What the names of the topic?
Block diagram. Block diagram.
Again. Block diagram. What the names of lecture 2?
Block diagram. Block diagram.
So simply introductions of block diagrams. That's why you call it the block diagram. So if that's the case, because a number of students in this class, they have attended the previous lecture. That was lecture what? Lecture 1. So what was the name, first of all? What was the title of lecture 1? How did we call lecture 1? Block what? Diagram. So the name of lecture 1 is called the block diagram. So what did we learn in in this lecture, in lecture 1? What did we learn? Meaning of what? Hey. So the meaning of what? A. So I gave you the first definition of what? Block what? Diagram. Then I told you the second definition of what? A. Of block diagram. Then I told you the third definition of what? Of block diagram. So you have three definitions, three different definitions about block diagram. You may prefer one, you may prefer two, you may prefer all the three. Then after that, I gave you some description. And there's one of the sentences that I've presented to you that each block or each subsystem of the entire system will be represented by a block. So it means that a block will be representing one subsystem. One subsystem. And then another thing that we say that these blocks represent what? Function. Functional parts or what? A process or what? Or subsystem. So the blocks representing function, the particular function, or process or subsystem. But again, we say that one block is connected with another block by using what? And lines is what? With arrows. Then another issue, we told you that the concept of block diagram is heavily used in what? Is heavily used in what? In engineering. To do what? You forgot. To design, design hardware, pardon? Software design. Software what? Control system. Designing control system, etc., etc. Then I present to you four main parts. Four main parts of what? Of the block diagram. Or what are the requirements, what are the essential requirements for the block diagram to be called a block diagram? The first one, we call it what? Block. The second one, we call it what? Line with arrow. Then the third part is called what? Label. Then the first part is what? Figure number, and what? Name of what? Of the block. Not the names of the block diagram. Name of the particular block. Then we discuss in detail about what? Block. Say block. So what the means of block we defined, and also we say that, or we give some examples of what? Of blocks. We say that a block can represent either a simple subsystem or a complex unit. Can be just a single unit or complex unit. That's what we've discussed. And today, let us continue the second part. That's called the lines with arrows. So this is number 2. It's called the lines with arrows. Lines with arrows. So lines with arrows. So the fundamental question, let us understand and let us ask ourselves what the meanings of this terminology. What is the meaning of line with arrow in electronics drawing? So what is the meaning of line with arrow? So you can even have some quotation like this. Line with arrow. So what the meanings of line with arrow? Line with arrow. So you say that in electronics drawing, a line with arrow is used to show, is used to indicate the direction of the directions of the, so it's used to indicate the direction of the electric current. Directions are electric current flow. It's used to show directions of the flow of electric current. Direction of the flow of electric current. So direction of the flow of electric current. So in electronics drawing, a line with arrow. So remember that we have a comma here. A line with arrow is used to indicate the directions of the flow of electric current, or sometimes is used to show the path. The path, or show what to indicate the path. Used to indicate the path of the signal, of the electric signal, the path of the electric signal or electric current. The path of electric signal or electric current, or to highlight the relationship between components, between blocks. So this is the meaning of a line with arrow in the context of electronics drawing. So a line with arrow is used to indicate what? To indicate the direction of the flow of electric current, or the path of the electric signal, or the path of electric current, or to highlight relationship between blocks. Separating. So in electronics engineering, a line with arrow is used to indicate the direction of the flow of electric current, or it's used to indicate the path of electric signal, or it's used to indicate the path of current, and it's used to indicate or it's used to highlight the relationship between what? Blocks. Are we together? Are we together? Are we together? So that's the meanings of the line with arrow. So that's the meaning. So we may not use the line itself without an arrow, because actually we want to have a clear definitions of what it has been stated. So simply, a line with arrow, it indicates what? So a line with arrow, it indicates the flow of electric signal. Line with arrow, it indicates the flow of electric signal. It also indicates the flow of electric power. It indicates the flow of energy. It indicates the flow of what? The flow of data between what? Consecutive blocks. So lines with arrow also indicate flow of electric signal, or electric power, or energy, or data between consecutive blocks. Class say flow of electric signal. Again, say flow of electric signal. First of all, greet your neighbor on your left hand side and right hand side, because your neighbor is completely unhappy. Greet your neighbor on your right hand side and left hand side, please. Say hello. So ask your neighbor, are you happy? Ask again, are you happy? Okay, so it indicates the flow of electric signal. Say electric signal. Say electric power. Or it indicates the flow of electric energy. Say electric energy. Or it indicates the flow of data. Say data.
Data.
Between what? Consecutive blocks. So when you hear about energy signal, data signal, electric signal, power signal, etc., etc., I know that in your mind you can create some questions, and one of the questions is, what the difference between power signal and the data signal, and what the difference between energy signal and maybe with electric signal. So you may ask yourself some questions about it. How many types of signals or electric signals do you have? Because those are the electric signals. How many? And mention those types of electric signals, because the arrows represent about electric signal. So I hate that question in my mind, and I would like to answer it in case that you are asking yourself about that question. So what do you say? We say that in electronics engineering, there are three main types of electric signal. Namely, the first one, we call it, we have power or energy signal. Say power or energy signal. Say power or energy signal. So when you talk about power or energy signal, this is the kind of the signal, or it's a type of the signal that we are using in the electronic system to provide power. So it's not the information signal that may be required to be processed by that system. No, it's just the power signal. The power signal, hello, I'm talking to you, what are you writing? The power signal corresponding to the nutrients in your digestive system. So the main function of the nutrients is to provide the energy to your body so that it can work. But actual, your main responsibility in life is not to think about processing the food which have been taken. Listen, for instance, myself, in the morning I took breakfast. You say breakfast. So when I took breakfast, I took just the food, and then I have some enzymes in my digestive system, which actually that will digest the food until we have the end product. We call it in biology. Say end product. What the end product of protein? What the names of end products of protein? Pardon? Amino acids. What the end products of glucose? So glucose is the end product. Is the end product of what? Which type of carbohydrate? Because you have 3 types of carbohydrates. Starchy. We have 3 types of what? Carbohydrates. Monosaccharides, disaccharides, and the polysaccharides. You forgot biology. You just studied a few years ago. Myself, I learned biology more than 17 years ago, and I still remember. So glucose is the end product of what? Monosaccharides or disaccharides or polysaccharides? Mono. And then sucrose is the end product of what? Sucrose. You say, we are engineers, we are no longer biology, But your entire body is all about biology. So, for instance, in the morning, I ate some sugar. So we expect that one of the end products in my digestive is glucose. Say glucose. So this is the end product. So the main function of the glucose is to provide energy. Now I'm teaching you because I'm using the energy provided by glucose of the food that I ate last night and the breakfast that I took in the morning. Are we together? But actual, so that's what, so it means this one can be corresponding with power signal in electronics. Power is actually providing energy to your body. Then right now, let's say that I'm teaching you. So when I'm teaching you, actually I'm trying to communicate. We're establishing communication. I am transmitting the information, you are receiving. Hello? What did I say? What did I say? Huh? I'm talking with this guy. What did I say? Huh? No, I'm no longer talking about the food I ate. I've been talking about what I'm doing right now. Energy is there. I have a decision, either to sleep or to work. Right? So when you're doing work, is actual, you are using this power in order to do work. So the work you are doing right now will be defined in electronics as, we call it information signal. Right now, I'm teaching you. So I'm transmitting the information you are receiving. So it means that when this process of teaching is actually called its information signal. It's not a power signal anymore. Are we together? So power or energy signal has a main role in the electronic system to provide the energy into the system. The system needs electric energy in order to work. Okay? Okay? But this power or energy signal, it's not the signal which is being processed by electronic system. No. The second type of electric signal, we call it the analogy or information signal. Information signal. You have to understand this. This is very important because, listen. There is no difference of a line with arrow using the representing power signal with the line with arrow using representing analog signal. There's no difference. The difference, actual, it will be depending on which block, where does the line come from, which block does the line come from, and which block does the line heading. Did you understand or should I repeat? Huh? Huh? Today you are completely unhappy. What's going on? Agat, please troubleshoot it. Troubleshoot her, even just to make her to be happy. She's come, give her some medicine. Give her some medicine. Give her some water. Hostel. So, for instance, when you, the nutrients, the end products that of the food that I ate, this represents the power or energy signal. But right now, I'm teaching you, and when I'm teaching you, the frequency of my voice is varying. It's going up and going down. So the signal that you are receiving in your ears from my mouth is actual, we call it analog or information signal. So I'm giving you information. Are we together? Are we together? Then, the third type of signal is called the data signal. Or in bracket, you can call it the digital signal. You have to understand this for the rest of your life in electronics and telecommunication engineering. Class, say power or energy signal. Say it loudly. Again, say analog or information signal.
Analog or information signal.
Then say data or digital signal.
Data or digital signal. Data or digital signal. Data or digital signal.
Okay. So when you talk about data or digital signal, this is a signal in terms of binary number. 0, 0, 1, 0, 1, 1, 1, maybe 0, etc. So it's digital information. When we talk about analog signal, this is the signal which is varying in magnitude with respect to time. Yeah? Pardon? I say digital signal, this is information signal that you may find in digital system or digital electronic system. The shape, the power signal, let us start. When you talk about power or energy signal, let me talk in terms of, let me actually go in detail, a little bit in detail. When you talk about power or energy signal, in terms of waveform, I don't know. Did I tell you that engineering is all about numbers? Engineering is all about diagrams? Have I said something like that? Huh? I haven't said that. Ah. So it's better to start from there. Then I'll come back here. So he said that, this is a very important sentence. He said that engineering and a field of engineering, including electronics or telecommunication, he said that engineering can be described by the following. I'm just jumping into this, then I'll come back there. Following 5 terminologies. So this is language of engineering. Engineering, simply said that engineering, A is electronics engineering or electrical engineering or communication system technology engineering, say that engineering is all about what? About the following. Engineering is all about numbers. Say numbers. Yeah. Say numbers. Yeah. Whenever you want to talk about engineering, sing to present your information or to communicate your information by using numbers. Say numbers. And then engineering is all about formula and equations. So whenever you want to communicate a message, engineering message, think about the formula required or the formula that might be used and the equations that might be used. Also, engineering is all about drawing, or we call them diagrams. Diagrams. And then engineering is all about table of results. Say table of results. Say table of results. And engineering is about graphs. So whenever you want to talk anything in engineering, sing to talk by using those 5 terminologies. Try your level best to think to talk in terms by using numbers, or by using formula and equations, or by using drawings or diagrams, by using table of results, by using graphs. So then, how can you prove that fact? Stop writing. For instance, in all-level physics, we have been taught physics practicals. We had mechanical or mechanics, light, and the electricity. Hello, I said stop writing, look and listen. If you do remember those questions the way that have been set, the first thing you'll be given a drawing of, or the set, drawing representing the set of the experiment. How are you going to arrange the apparatus? Okay? Then after that, you'll be given instruction, actually, that if it is, for instance, we are talking about the simple pendulum. So this is the simple pendulum, then this is the bulb. So this is the rate of distance. So you see the figure or the diagrams of rate of distance. We said engineering is the purposeful use of science. So I want to use the science and mathematics that I've been learning to present, it means to translate or to define how we use them in engineering. Are we together? Are we together? So this is the bulb, this is the pendulum, this is what rate of distance. Then you might be given, not you might be given, you'll be given a stopwatch. Then you'll be given instruction that, okay, swing the bulb in a small angle in such a way that, and then count it or measure the times when you have 20 oscillations. Okay? After that, you'll be given, or you'll be asked that to present your results in terms of the table of results. So, this is the table 40 of results. Because I told you there's a close relationship between mathematics, engineering, and science. Then after that, hello. Then, for instance, in this table, we are going to have what? Period. Then we are going to have what? Period square. Then we are going to have length, for instance. Then we'll be asked if I just repeat the process for 4 times, for instance. So you'll be measuring the period, then you'll be filling the blanks, or filling these cells. After that, you'll be squaring what you have measured here, and then you'll be measuring the length by using the meter ruler. So this is actual table of results. So in engineering, we have a number of table of results. Are you together? Then, after that, you'll be asked to draw the graph. The common graph that you've been asked to draw is draw the graph of square of the periods against the length of the pendulum. Are you together? Are you together? Are you together? And in most cases, so you locate your points from the table of results. Maybe that this one will draw the straight line. So this is all about graph. And this is all about table. Are we together? Yes. Are we together? Then after that, you'll be given some questions. And one of the questions will be asked that find the gradient of the of your graph. Then you know that the gradient is equal to what? Change in y over change in what? Say change in y over change in x. So for our case, gradient for this system will be change in period or square of the period over change in what? What is this? Formula. So this is the formula. They are using the formula. Okay? Okay? Then after that, you'll be asked that, you'll be given another or mathematical formula. Okay? Or the formula. And the formula that will be given for this case, be asked that period can be computed for the simple pendulum is equal to 2 pi over length, square root of length over gravity. You'll be asked to use this equation in gradients to find what the value of acceleration to the gravity. Are we together? So then we say in engineering is all about numbers. So when you find the gradients, you'll have a number. When you find acceleration gravity, you'll have a number. It's a number. Are we together? And you know that this is simple because if you square both sides, you have period square is equal to 4 pi square length over what? Over g. So this one, if you compare with y, is equal to mx. Y is equal to mx. So the gradient change in t square over change in length, this is equal to what? 4 pi square over g. You cross multiplication, you find the value of g. This is all about mathematical equation and mathematical formula. But finally, the value of g will be a number. That's from what? Science perspective. And then we say that it's all about drawing saw diagrams. So it will be simple for you to set up the experiments of the simple pendulum because you have the format. How it means you've been given a diagrams or a drawing that can help you to set up. Okay? Okay? Then we say the engineering is all about table 40 results. So this is the table of results. Engineering is all about 30 graphs. This is the graph. So if that's the case, if you agree that engineering is all about numbers, it's all about table of results, it's all about diagrams or drawings. Engineering is all about formula and mathematical equation. Engineering is all about graphs. During your form for education, you had a graph pad. Say graph pad. In order to draw different graphs. But once you came for the engineering, electronics and telecommunication engineering, this is the 8th week. But ask your neighbor if he or she has a graph pad. Ask your neighbor, do you have a graph pad? Do you have a graph pad for electronics and telecommunication engineering? If the answer is yes or no, then ask him or her another question, the second question. My neighbor, have you ever drawn any graph in electronics and telecommunication engineering? No. So if the answer is no, it means that tell your neighbor that I appreciate that you are a real politician in electronics and telecommunication engineering. Why? Because you cannot say that I'm learning electronics and telecommunication engineering and then you don't draw even one graph in a week. So you are learning political electronics engineering and the political telecommunication, but you are always defending yourself, I won't be a politician. Well, being a politician is not just until you are going to contest for member of parliament or president. No. You may be a political engineer. And we have so many political engineers in our country. Together, class? Are we together? So why did they mention this? Because you will see the importance of drawings or diagrams. I just wanted to draw the graphs. I want to explain about power signal, analog signal, and data signal by using graphs in order to give you the picture of how we can differentiate them. Are we together? Malaika has the questions. Welcome. Pardon? Number 1, yes, it's called the power or energy signal. Number 2, analogy or information signal. They have resemble? No. They are completely different. So what's your question? How do they resemble? I didn't say that they are resemble. These are the 3 different signals. Sometimes the nature of the power signal, the nature, not the magnitude. The nature of the power signal and the analog signal might be the same, but not the magnitude. Class, is it clear? Write this. This is not a story. Rhoda is chatting. Rhoda is chatting. Rhoda say, right now, let me take my handbag and call somebody to keep lunch for me. So simply by using graphs, I can explain these 3 types of the of the electric signal. Then we have to move into the next part. For instance, in electrical engineering and electronics, we can have DC power signal. So if you have DC power signal, we may have DC power signal, and also may have AC power signal. So for this case, what do you say? DC power signal, the waveform for DC power signal will be like this. Will be varying with time, and then this is voltage. It will be a straight line. Hello, stop writing, look on the blackboard. Then the waveform for the AC signal, for this case, this is voltage, this is time. So it means that the waveform for this case, here we have the AC. So that is AC power signal. Okay? Okay, class? AC power signal. That's the waveform. Then when we talk about analog signal. Analog signal. Analog signal is a continuous signal. Analog signal. We may represent the analog signal as sinusoidal signal or waveform. So this is the shape of what? Analog signal. So it's a continuous signal. Analog signal may be called the continuous signal. So this is 0, depending on the frequency. This is the analog UT, waveform for analog UT. Eh? So sometimes the nature of the waveform for analog signal is the same with the nature of AC power or energy signal. The nature of the waveform, not the magnitude. In most cases, AC power signal has a very high voltage compared to analog signal. This one is measured in terms of voltage. For instance, in Tanzania, we can have 240 volts. And also, when you visit TANESCO, you may have 11 kilovolt. It means 11,000 volts. So that's what we talk about magnitude. But in case of the information analog signal, in most cases you find that the magnitude means that the amplitude of the analog signal is measured in terms of millivolt. Okay? Okay? So this is measured in terms of millivolt, while in case of AC, we say that the signal is measured in terms of volt or in terms of 40 kilovolt. Say kilovolt. Yes, at TANESCO or in our domestic places, we used to receive 11 kilovolt from our power supplier, from power source. Then we have the nature of 40 of data or digital signal. So the nature of data or digital signal. So the nature, the waveform, if you draw the waveform of the digital signal, well, so you'll have in vertical axis, you have voltage, horizontal axis, we have time. Then, if that's the case, what do we say? This is 0. So you have this one. This is digital signal. So for this case, what do we say? We say that this is binary number 1, this is binary number 0. This is binary number 1, this is binary number 0. This is binary number 1, etc., etc. So these are sometimes we call them spaces, but they're not actual. We call they are just we call them spaces. So this is what we call the data or digital signal. Are we together? Are we together? So in real life, it means that this is 5 volt. When you say binary number 1, we means 5 volt. When you say that binary number 0, we means 0 volt. So for this case, the maximum voltage is 5 volt. At this point, the maximum voltage is 0, or the minimum voltage is 0. Then 5 goes to 5, 0, 5, 0. That's the meaning of digital signal. Can you pass there? Are you Salehe or Swalehe? Okay, introduce yourself, then ask your question.
Sir, I just want to ask why technicians move from analog to digital signals? What happened? What caused a technician to move from analog to digital signals?
Okay, well, it's a good question. First of all, you have to know that the world where we are living. Did you understand this question? No, you didn't understand because you are just drawing. And the leader for drawing is Mr. Abdurrahman. And the assistant is Naomi. Mr. Of course now is just waiting me to turn back to the blackboard and then we'll be drawing. His question is, what make our technicians to move from analog to digital? Or what makes digital technology to be available? What is the cause? Why the world wanted digital technology? Okay, your questions is good. However, that it's out of this subject, but let me just give you a brief description. First of all, the world where we are living is pure analog. I don't know if you understand that sentence. Say, the world where we are living is pure analog. Again, say, the world where we are living is pure analog.
The world where we are living is pure analog.
Shifra yourself. Say it 3 times. Eh? 3 times. Shifra was not in the class. Class, say that with the world where we are living is pure analog.
The world where we are living is pure analog.
So what does it mean? The physical phenomena that we have in this world are analog in nature. So when you say that they're analog in nature, what does it mean? It means that they are continuous, or they have continuous variation with respect to time. One example, it's my voice. My voice is not a digital signal. My voice is analog signal. It's varying as time goes. If it is digital signal, I could just have 2 states, high and low, high and low. So that's one of the key concepts. Then, to process the analog signal, which is come from the real world where we are living, by using analog circuit is difficult. Is what is extremely difficult to process, or to transmit, or to control, or to manage, or to convey any signal in analog form by using analog circuits. It's difficult because of the limitations of those analog circuits. For instance, if you are using analog system to transmit voice from here to Mwanza, then the signal will reach at Mwanza while it is totally attenuated. So the receiver will receive 0 signal. Okay? So for that, if that's the case, then electronics engineers and electronics engineers conducted a number of research. Then they discovered that yes, we can receive the analog signal from the real world and convert it into digital signal, process, transmit, and do whatever we can do. But at the receiving ends, then we'll convey the digital signal into analog signal, because the destination part, where the actual, that is the real world part, could understand the only analog signal and not the digital signal. I think it's enough. Don't allow me to go further because you'll get confused completely. But I leave a question to you. If digital technology or digital industry, or say that digital industry is powerful or is more advanced compared to analog, why do you still Why do you still have analog? Why should not digital signal face analog completely? I've already answered that question when I've been answering Swalehe's question. But because you are just waiting me to write and then go back and cram, maybe you didn't catch up. So let me give you a simple example. Listen. For instance, you used to call your father. Ask your neighbor, do you used to call your father? Ask your neighbor, do you used to call your father? So when we're talking to your father, your voice is analog. Within your mobile circuit, there are some circuits, or a number of circuits, and one of the circuits is a circuit that's called the analog to digital converter, ADC. That will convert your analog voice into digital. Then this information will be processed, sent to the BTS, the nearby base transceiver station, and send it to the control network. And will be processed, sent to Mwanda, maybe out to Kigoma or to Katavi. And after that, then the information will be processed. Then it reaches to your father's mobile phone. Remember that your father's ear cannot hear your voice in digital form. So at your father's phones, there are also another converter of the signal that's called the digital converter to analog, DCA, digital converter. Mr. T, analog digital converter, and this one digital analog converter. Digital analog digital analog converter. So you have sent the analog signal, which is your voice. It has been processed in form of digital. Then at the destination, within your father's mobile phone, there's also digital to analog circuit that conveys digital signal into analog. So your father will hear your analog signal. That's what is happening. Are we together? So examples of arrows that you are using in electronics, examples of arrows. Say examples of lines, with examples of lines. Lines with what? Arrows used in electronics. So let us see some examples of those lines with arrow or arrow lines. Then these lines can have different size and different directions. Stop writing. And in most cases, you'll find that the line with arrow will be actual. We used to draw from left to right. Hello. Hello, Jackie. How are you, Jackie? Where are you? Are you in Arusha now? Huh? Are you on the way to Arusha? Via what, Bagamoyo Road or via Chalinze Road? Or via Namanga Road? Via Kiboroni Road, yeah? Okay. Okay, so we say that this is the meaningful. With this arrow, this means that source, destination. Hello? This is a source of electric signal, or it's a source of power signal, or analog signal, or data signal. And this is the destination. Are we together? This is not the source and this is the destination, no? Again, these arrows sometimes may be, so it means that when you see this arrow has been drawn, we expect here to have one block and we expect here another block. So at the source we have one block, at the destination we have another what? Another what? Also sometimes you may have one block on the top and another one's at the bottom. So these arrows also can be drawing vertically. This is the source of the electric signal, power signal, or information signal, or what? Or data signal. Are you together? These arrows also, sometimes maybe the source is the block at the top, while the destination is at the bottom. So the arrow might be pointing down. And especially for the power supply, we'll find that the arrow that is pointing down. Are we together? And then sometimes you may find these arrows are long. Sometimes you may find that one block is here, another block is there. Sometimes you may draw these arrows in this style. That maybe we draw like this way. We draw an arrow from one block here. Then we transfer the electric signal into another block. So this can be drawn like this. Or sometimes we can have that this arrow is drawing, there's a one block here, and then transferring electric signal to the next block. So you have different style. Wewe, simama juu wote wawili. Simama juu. Yes, you and you. Including you. Okay. So, for this case, you can have different shapes of the arrows. And sometimes, you might find that you have one block, but this block has to supply energy into more than one block. So you may draw an arrow, that's we call it a network arrow, like this one. This is the network arrow. Students, these are the principles of drawing block diagram. Listen, understand, and keep for the rest of your life. Then at this point, we'll have another arrow, maybe heading to another block. Then at this point, we are going to have another arrow heading to another block. So these arrows may have different shapes. You can have a 3-network arrow or 2-network arrow. You may also have another arrow that maybe moving from one, you have one block that is a source block, a source of the information, and then it's sending the electric signal into 2 different blocks. You may also have this kind. Usually it's not allowed for the lines to intersect, usual. But sometimes, because you don't mind, you may draw a block diagram where lines have been intersecting. Naomi, you are busy. I think that you have been busy listening to the music which has been played there. Okay, so you can have something like that. Also, you can have another arrow. So everything that I'm drawing here, you are going to apply. So just keep on enjoying the music outside. Then let me keep on teaching. Yes, yeah? Okay. So you may also have a network arrow like that. And remember that those lines are straight lines. And they can either, and those straight lines we have drawn, in most cases, they should be 90 degrees. It's not allowed to draw an arrow from one block in this style, no. Stand up. Stand up. Class, are we together? So this one, we call them simple. So these are the simple lines with arrows. Simple lines with arrows. I say stand up. I know, yes, you are sick. Just stand up there. It's another part of practice. Okay, go and stand there at the back. So these are the simple lines with arrows. But sometimes in some of the block diagrams for the special application, especially in computer system, you may find that the arrows which have been used are not simple lines with arrows like that, but we call this block arrows. Lines is block, or we call this block arrows. Block lines or block arrows. So number 2 or number B, we call them, these are block arrows. But remember that these block arrows are used for the special blocks, block diagrams. Diagrams, especially in complex or computer system. But some students, they may use these blocks wrong. When they are drawing just a simple electronics, students, you are busy on drawing. You have to listen first. Say block arrows. Help me there. Say block arrows.
Block arrows.
Say block arrows.
Block arrows.
Usually in electronics you may use just a simple lines with arrows in drawing different block diagrams. These are enough. But because you'll be doing different studies, you'll be have different modules, you may find some block diagrams, uses block arrows, and then ask yourself for questions. Olenjolai did not teach me about this thing. What's going on? Who is correct, Olenjolai? Or maybe they are the person who drew these block diagrams by using block arrows. So the block arrows in software engineering, we can have of the different style. You can find that a block arrow looks like this one. I say this, stop drawing, listen and watch. So this is what we call the block arrow. Say block arrow.
Block arrows.
Then you can have another block arrow where so this is the source, this is the destination of the signal. Then you can have a block arrow heading downward. We can also have a block arrow heading up. I told you that I've never taught any students these tricks that I'm teaching you. I've been hiding. So I want you to be best students in drawings, the block diagrams, even more than me. But if you work hard, if you are just waiting exams, then I want to tell you that you will enjoy it. But sometimes you can have a block arrow, looks like this. Have another block arrow. So what does it mean? You may find that on this side you'll have block 1, on this side you'll have block 2. That means on this side you can have, let's say, block 1, on this side you'll have block 2. On this side you'll have block 1, on this side you'll have block 2. On this side you can have block 1, on this side you can have block 2. That's the meaning. So this is a two-way flow of information. So this is acting as a source to this, and also this one is acting to the source to this. So it's a two-way communication. It's a two-way what? While this one is one-way communication, one-way communication, one-way communication. It's actually the signal move from the source block to the destination block. While for this one, they move from source block to destination, and also from destination to source block. So when this one moves from this side, this is the source block, this is the destination block. When moving this direction, this is the source block, this is the destination block. Sir, what? There is no sir. Question about lines with arrows. Let us start with Angelica. Sit down. Can you speak loudly? Just as how you provide announcement in class.
Okay. Simple lines have two ways.
Simple lines. Like block arrows. I haven't seen. I haven't seen. However, sometimes if maybe, did you hear her question? So Agape answer? Answer Angelica's question. Brother Talam, answer Angelica's question. Not now. Diana, answer Angelica's question. Agape. Mfaume. Agape. Tell us, Agape. Try. I said I haven't seen. How about you? Have you seen it? Did you even think about it? Even Agape said that I haven't seen. Tell us. Tusomeshe na sisi tuelewe. Tusomeshe pale. Hebu tusomeshe tufahamu. Au hujamfahamu bado?
Sikauliza yani two way inaweza kawa change of information from one to another ahead
in simple lines.
in simple lines. I think
You think?
inaweza kawa inawezekana.
Okay. So this is the response for that question. You can have block 1. Sometimes you can find the two ways flow of the information in electronics diagram. Hello? Hey. Bongo students. They are very good in writing. Very good. And not even very good, expert. Do you see the one? Do you see there? Expert. He has been sitting, I punish him to stand up. Then now I say, okay, give me the second permission. So suppose that this is block 1 and this is block 2. Then maybe there is a two-way flow of data. So if you're using the simple lines, in some cases, or in most cases, we use 2 lines. 1, and then you use this one. Okay? Okay? Wait, Jackson had a question. Just gonna ask it. The same question. Hey, what's your name? Daniel.
For that group, you can't use only one line. They are arrow.
Pardon?
For those 2 blocks, you can use one arrow.
Where? In simple lines with arrows? Yeah. So Daniel is still asking the same question. He said that in simple lines with arrows, can't we use a single line with 2 arrows? What have been answering? Dan, you are not there? You are there. What did you understand? I said, in case of the simple line, if you have one block here, and then you have a second block here, if you have 2 ways of flow of information, we may draw 2 arrows. 1 and this one. Another question? Nehemiah, you have a question? Give Nehemiah a microphone. Nehemiah, Nehemiah is asking question. And you don't have a question? You're just receiving. Comment ça va, eh? Tell us, Nehemiah.
Okay. My name is Nehemiah Peter. I want to ask, I've saw some of the arrows, in the simple arrows, some of them are looking like bolded. What is the difference?
There's no difference. You may either use a bolded arrow and even these kinds of the arrow. Yeah, so there's no any rule that maybe you have to use a bolded arrow or unbolded arrows, no. The matter is just an arrow, and it should be just a simple arrow. Brother, what's your name? The same question. So you have the same mind. Now Rhoda is asking a question. Pass the microphone to Rhoda and turn it on, because sometimes some of them, they don't know how to turn it on. Mister, of course, you have a question? You have a question? Tell us, Rhoda. Ask him.
I was asking, is it possible that and we see that one edge goes like this? Can that one also goes like this?
Having a network of block arrow.
Yes, and the edges.
So Rhoda is asking, is it possible that to have a network block of arrows, let's say 2 block arrows, yes, which have been interconnected, yes, or maybe a block of 2 block arrows in this style, yes, or maybe a network of 3 block arrows.
Yes.
I haven't seen. Maybe they're there, but for myself, I haven't seen. Another question? Mr. Of course, he said he had a question. What's your name?
My name is Elisha.
Elisha. Elisha of that wonderful book, or Elisha of Bongo?
Maybe.
Maybe. That wonderful book, eh? Okay.
My question.
Tell us. Ask your question, Elisha.
I have a question.
Uh-huh.
You said to use those line arrows
Uh,
if there is a 2 blocks. So if you have one power supply, we'll use 2 arrows to show the current flow or 1 arrow.
Very good question. Clap your hands for Mr. Of course. Mr. Elisha, not Mr. Of course. Clap your hand for Mr. Elisha. Okay, Elisha's question is this one. Very important question, and it's better to address it. Suppose that you have a block, we call it a power supply unit. Power supply unit. And then you have another block, which you call it sensing or sensing unit, for instance, that need power, right? Then you have another block, let's say that this block, we have a block where we have control unit. And maybe you can have another block where that we have display. Let's say display. So Elisha asked a question. For instance, it means that for this one to supply power, you need to use these arrows. Let's say just between these 2 blocks. So Elisha asked this question. In case of the flow of electric current from one point to another point, we always use 2 wires. Okay? Maybe this is in most cases this is the red wire and this is the black wire. So in order for the current to flow from one point to another point, we need 2 wires. So the red wire actually be sending power to the secondary destination. Then the black wire will return. Okay? Then Elisha's questions is this one. If this is the principle of flow of electric power, right? That actual electric power should be established complete loop. How about in block diagrams? Should he use 2 arrows to show that the power is being the power is flowing from the power supply unit to the control unit and returning back? The answer is no. Why? Just this single arrow represents the 2 wires. And the importance means that in case of block diagrams, our main focus, we focus about just the ready, or just the arrow will be representing the ready wire, just we call it the ready wire that is carrying current from one point to another point. We are not interested with returning current. Did you understand what I said? Yes. Did you understand what I said? Yes. Maybe you did not understand, or you have understood, but within a short time you have forgotten. Let me give you another example. In order in the real situation, in order to take power from the power supply into the sensor unit, you need 2 wires. Right? One is positive, the other one is negative. In case of the block diagrams, we don't draw the 2 wires or the 2 arrows. We just draw one line. For instance, from here to the sensing unit. That's all. Why? Because remember that we can have a single wire, but within we have 2 wires. Unaelewana? Eh? Do you know about coaxial cable? Out is IP cables, zile cables za internet. Unazifahamu? Shai kuziona? Zina nyaya 8 kwa ndani yake, lakini ni cable moja. Yani one cable can carry more than 1 wires. Sawa? But in case of block diagrams, our focus is the flow of current toward a destination block. Our focus is not the returning current. Are we together? Again, so we don't draw another block. So what Elisha was asking, should we draw another block that will be returning current like this? The answer is no. So if you want to power this block, you want to power the display block, then this is the way. So you just have only 3 arrows. But in real implementation, in real implementation, you need 2 wires to transfer power from here to here. You need 2 wires to transfer power from here to here. You need 2 wires to transfer power from here to here. And this is what we have been calling power, shifra, power or energy signal. Power signal, power signal, power signal. This is all about power because it comes from the power supply. It's not the information which has been processed. The information signal is if the sensor gives output to the control unit. Another information or data signal is actual when the control unit processes the information and sends to the display. Class, are we together? Okay, draw now.
Wabariki